So let's take a look at a couple of examples. What would the reference angle measurement for an angle of 71 degrees in standard position be? I'm going to pause. You figure it out. Hopefully that's the answer you got, because in quadrant 1, our reference angle is the actual angle. What is the reference angle measurement for an angle of 133 degrees in standard position? I'll pause. Hopefully you got 47 degrees. We want this angle here, which would be everything left over from our original angle. The sum should be 180, so we're going to take 180 minus 133 to get 47 degrees. What's the reference angle measurement for an angle of 254 degrees in standard position? I'm going to pause again. Hopefully you got 74 degrees. So our reference angle would be right here, attached to the horizontal axis, and we can see that since our original angle was here, we could take 180 degrees and add it on to our reference angle, or subtract 180 from 254. Finally, what's the reference angle measurement for an angle of 317 degrees? So our initial angle here, 317 degrees. I'll pause. Hopefully you got 43 degrees. We'll draw the reference angle. Again, the positive acute angle connected to the horizontal axis, which we could see one way to get that would be to go 360 degrees and figure out the difference between our original angle and 360 degrees. So 360 minus 317 will give us 43 degrees. All right, let's do a quick recap of our strategy depending on the quadrant. If our original angle is in quadrant 1, the reference angle will just be the angle. In quadrant 2, we'll take 180 minus the angle to find the reference angle. In quadrant 3, the angle minus 180 degrees. How much further than 180 degrees did we go? In quadrant 4, finally, we can get the reference angle by taking 360 minus the angle. Let's take a look at a slightly more challenging example. Let's take an angle of 4,897 degrees in standard position and determine a coterminal angle between 0 and 360 degrees. So 4,897 degrees is a lot of times around the circle. In fact, when we do that, we see this many times around the circle. So our first angle, so here's 360 degrees, 720, and so on until we end up with an angle that ends somewhere out here. So if we want to determine a coterminal angle between 0 and 360 degrees, we need to find out how many times we've gone around the circle so we can subtract those revolutions from our angle. So the way I'm going to do that is I'm going to take that 4,897 degrees and I'm going to divide by the number of degrees in each rotation. So I see that I've gone 13 plus a fraction of a time around the circle. So what I'm going to do is I'm going to take my answer and subtract the 13 and find this fraction of a circle that I have left over. I'm going to take that fraction and multiply it by the 360 to see how many degrees that actually actually is 217 degrees. Okay, so naturally, with that 217 degrees angle, I'm going to follow up with asking you for the reference angle for an angle of 4,897 degrees. Well, 217 degrees is in the third quadrant, so we know we just take 180 and subtract it from our 217 degrees. And we should get, yes, 37 degrees. And that's our lesson.